You know, we often think of the universe as this huge, bright place full of galaxies shining across, well, unimaginable distances. But what if, just imagine for a second, the early universe was actually furried with this thick fog, so thick that the light from the very first stars, the first galaxies, it just couldn't get through easily.
Right. That's actually a really good analogy for what we think it was like.
And that's really our starting point today for this deep dive into a discovery from the James Webb Space Telescope that's, well, frankly, it's pretty groundbreaking.
It really is. Because for hundreds of millions of years right after the Big Bang, the universe was just packed with neutral hydrogen gas.
Neutral hydrogen?
Yeah, think of it like a cosmic mist everywhere. And any light trying to travel through it, especially that really energetic ultraviolet light that young, hot galaxies pump out, it would have just been soaked up, absorbed.
So like a cosmic blackout for certain kinds of light. We call that the dark ages, right?
That's the period, yes. The cosmic dark ages. Because it was opaque to that kind of light.
Okay, so universe starts out foggy. Got it.
Right.
But, I mean, obviously didn't stay that way. Things cleared up eventually.
Exactly. We think the first stars and galaxies started churning out so much powerful radiation, especially UV light, that they began to interact with that neutral hydrogen, zapping it, basically.
Ionizing it.
Precisely. Ionizing it. That's the process we call reionization. It's sort of like the sun burning off morning fog here on Earth. It gradually made the universe transparent again.
But that took time, right? The thinking was this whole clearing process wasn't really finished until maybe 1 billion years after the Big Bang.
That was the standard picture, yeah. Around 1 billion years post-Big Bang for the fog to completely lift everywhere.
Okay. And there's a specific kind of light that's really important here.
Yes, Lyman-Alpha Emission. It's a particular wavelength of ultraviolet light. It's basically a fingerprint, a signature that hydrogen atoms give off when their electrons, drop down to a lower energy level.
Right.
But because it is ultraviolet, it should have been, well, massively scattered and absorbed by all that neutral hydrogen fog back in the really early universe.
So finding a strong signal of that specific light from a galaxy way back then, that would be weird.
Extremely weird, yeah, like hearing a clear whistle from someone deep inside a huge, dense forest. You just wouldn't expect the sound to travel that well.
Okay, brings us perfectly to the James Webb Space Telescope, our amazing eye in the sky, built specifically to look back into that deep past.
Exactly. And one of its big jobs, its key missions, is studying those very first galaxies. And boy, has it delivered with this discovery, a galaxy they've nicknamed JADES GS-Z13-1.
JADES GS-Z13-1. And the JADES part refers to the survey program, the JWST Advanced Deep Extragalactic Survey.
That's the one. And what's just stunning isn't only how far away this galaxy is.
How far are we talking?
Well, its light has been traveling for about 13.47 billion years. So we're seeing it as it was only, get this, about 330 million years after the Big Bang.
Wow. Okay, that is early. Like, cosmically speaking, that's infancy. A tiny fraction of the universe's age.
Tiny sliver, yeah. But here's the kicker, the really unexpected part. This tiny infant galaxy is shining brightly with that exact Lyman-Alpha emission we were just talking about.
Hold on. So Webb sees this galaxy way back when the universe should have still been full of that hydrogen fog, and yet it's pumping out this specific UV light that the fog should have blocked. It's like finding a really bright flashlight beam cutting straight through a room that's just totally filled with thick smoke. You shouldn't be able to see the beam itself, right?
Precisely. That's a great way to put it. The team, they first spotted this object using Webb's near-infrared camera, NIRCam.
Okay.
By looking at how bright it was through different infrared filters, they could get an estimate of its redshift.
And redshift is like the stretching of light as the universe expands. More stretch means farther away, further back in time.
You got it. The initial estimates put it way out there. Very high redshift, indicating it was from that very early time.
But they needed to be sure, right? An estimate isn't proof.
Correct. So they brought in another of Webb's amazing instruments, the near-infrared spectrograph, or NIRSpec.
Ah, the spectrograph. That splits the light up like a prism into its component colors or wavelengths.
Exactly like a prism, but for infrared light. And when they analyzed that spectrum, that rainbow of light from the galaxy, boom, they confirmed the redshift. A redshift of 13.0.
Which puts it right at that 330 million years after the Big Bang mark.
Dead on. But then also in that spectrum was this really prominent spike of light at one very specific wavelength.
Don't tell me.
Yep, the unmistakable signature of Lyman-Alpha emission. Clear as day.
Wow. I read that someone on the research team actually described it as finding a beam of light from this galaxy piercing the veil.
That quote really captures it, doesn't it? Because our whole understanding of that early time, that foggy era, suggested this kind of UV light just shouldn't have made it across such vast distances. It should have been absorbed by all that neutral hydrogen gas floating around.
Right, because usually when astronomers look at really distant galaxies, even ones maybe a bit later than this one, they see the opposite, right? Like a dip or a break where that UV light should be.
Exactly. You see that drop off, that absorption signature. It's expected. It tells you the light encountered that neutral hydrogen fog. But with JADES GSZ13-1, nope. We see this strong, clear emission signal. Something powerful is generating UV light, and somehow it's getting through.
Okay, so this is the core puzzle. How is this light escaping? How is it reaching us from so early on? What is going on back then that maybe we didn't quite grasp?
Well, scientists are digging into some really fascinating possibilities. One of the main ideas, the leading hypothesis, is that maybe this galaxy, JADES GSZ13-1, managed to create a huge bubble of ionized hydrogen around itself.
A bubble. Like it cleared out its own neighborhood.
Sort of, yeah. Imagine, like you said, a super powerful spotlight in that foggy room. If the light is intense enough, maybe it can burn away the fog right around it, creating a clear path.
Okay, I can picture that.
So in this cosmic version, the galaxy's own intense radiation might have ionized, zapped a huge region of the hydrogen gas immediately surrounding it, creating a transparent channel for its Lyman-Alpha light to escape through.
Wow, that's quite an image. How big would that bubble need to be?
Well, the estimates are pretty staggering. They think this bubble of cleared out ionized hydrogen could be something like 200,000 light years across.
200,000 light years, that's huge. How big is our Milky Way?
Our Milky Way is roughly 100,000 light years in diameter.
So this bubble, this cleared patch, would be twice the size of our entire galaxy, created just 330 million years after the Big Bang.
That's the estimate, yeah. And creating a zone like that early on, well, it would require an absolutely extraordinary amount of ultraviolet radiation pouring out of that galaxy.
Okay, so where does that much UV radiation come from? What kind of cosmic powerhouse could possibly do that so quickly after the universe began?
That's the next layer of the mystery. There are maybe two main suspects.
Lay them on us.
Okay, suspect number one, a whole bunch of extremely massive, incredibly hot, and super luminous first-generation stars. We call them population 3 stars.
Pop 3 stars.
Yeah.
The very first stars ever. The ones made of just hydrogen and helium from the Big Bang.
Those are the ones. We theorize they could have been very different from stars today, maybe much, much bigger, much hotter. And as a result, they'd blast out way more high-energy UV radiation than typical stars we see now.
That's amazing, because we've never actually seen a Pop 3 star directly, have we? Theoretical.
That's right. They would have burned out very quickly. So finding evidence like this huge ionized bubble, could it be an indirect sign? A sort of fingerprint left behind by these mythical first stars lighting up inside JADES GSZ13-1.
That would be incredible. Okay, what's suspect number 2?
Suspect number 2 is maybe even more dramatic. A powerful active galactic nucleus, an AGN.
AGN. That means a supermassive black hole at the galaxy's center, right? One that's actively feeding.
Exactly. A black hole gobbling up surrounding gas and dust. As that material spirals in, it gets superheated, incredibly hot, and blasts out enormous amounts of radiation across the spectrum, including that intense UV light we need.
So it could be a black hole that got supermassive, super fast, and is having a huge meal right at the dawn of time.
It's a possibility, and if that's the case...
Wow. What would that mean if there's a giant active black hole there already?
Well, if JADES GSZ13-1 really has a supermassive black hole powerful enough to clear out a 200,000 light-year bubble just 330 million years after the Big Bang, it would have to be one of the earliest and probably one of the most massive black holes we've ever found evidence for.
And that would be hard to explain, how it got so big so quickly.
It could definitely challenge our current models of how black holes form and grow. It's like finding a giant, fully grown oak tree just a few months after you planted the acorn. How did it get so big so fast?
Okay, so either way, whether it's powered by these exotic first stars or a surprisingly huge early black hole, it's a revolutionary finding.
Absolutely. And, it's also possible it's not either. It could be a combination of both. Maybe there are lots of massive stars and an active black hole working together.
Right.
The bottom line is we don't know for sure yet what's driving this intense radiation and carving out that escape route for the Lyman-Alpha light. And that's what makes it such a fantastic, compelling mystery for astronomers right now.
This discovery really does, it shakes up our neat picture of the early universe, doesn't it? That smooth transition from foggy to clear might have been Messier.
It certainly suggests that. Finding strong Lyman-Alpha from this early suggests that maybe the fog wasn't uniform. Maybe there were pockets, clearings, islands of transparency that formed much earlier in some places than our models generally predicted.
Islands of sunshine in a totally overcast sky, like you said earlier. I like that.
Yeah. And it's not just about the timeline. This finding also gives us really valuable tangible evidence about how Lyman-Alpha photons actually interact with neutral hydrogen gas. There's a process called Wood-Wouthuysen field coupling.
Okay, sounds technical.
It is a bit technical, but it's basically about how this light affects the hydrogen gas itself even before it fully ionizes it. And understanding that is crucial for interpreting signals from the early universe, especially for future radio telescopes trying to map that hydrogen directly using something called the 21-centimeter signal.
So this helps us understand the physics of that whole reionization era better. And you can bet we'll be covering those future discoveries right here on Cosmic Origins Revealed.
Definitely. And another point, this galaxy, JADES GSC 13-1, was found in what's actually a fairly small patch of sky that Webb surveyed.
Really? Not like a huge all-sky survey.
Relatively small, which hints that maybe these kinds of extreme early bright galaxies aren't super rare flukes. Maybe they're actually more common than we thought.
And if that's true, it could really change our ideas about how quickly the first galaxies got going and how reionization actually happened overall.
Exactly. It opens up a lot of possibilities.
So what happens next? Are they pointing Webb back at this galaxy for a longer look?
Oh, absolutely. You can be sure the team is already planning follow-up observations. They want more data, deeper spectra.
To try and figure out what's inside, pop 3 stars or black hole.
Precisely. They want to really nail down the properties of this galaxy, understand its stars, look for any other signs of what might be powering that immense UV output and clearing that bubble. Is it the stars? Is it a black hole? Is it both? Hopefully, future Webb observations will give us more clues. And of course, Cosmic Origins Revealed will keep you updated.
It's mind-bending when you stop and think about it. This tiny speck of light representing a galaxy from so long ago, managing to shine through that primordial fog, when, by all rights, it feels like it shouldn't have. It's just an incredible testament to the power of this new telescope, JWST, and the scientists figuring out how to use it to find these things. And sharing these discoveries with you is exactly why we do Cosmic Origins Revealed.
Yeah, this one finding just blows open so many questions about the universe's very first moments. What were those first stars really like? How did the first supermassive black holes get so big so fast? And how exactly did that transition from an opaque, foggy universe to the transparent one we see today actually unfold? JADES GSZ 13-1 sitting there 330 million years after the start, shining like that. It's just a beautiful, profound puzzle. And you can find more deep dives into puzzles like this on our Cosmic Origins Revealed channel.
It really is awe-inspiring, thinking about the sheer scale of it all and how we're just starting to piece together these earliest chapters of the cosmic story. Discoveries like this, they just remind you how much more there is to learn, how much the universe still has to surprise us. And you can absolutely count on Cosmic Origins Revealed to be right there, bringing you along for the ride as we explore these cosmic mysteries.
Definitely. So if this journey back to the cosmic dawn has sparked your curiosity, please do check out the Cosmic Origins Revealed YouTube channel.
Yeah, we've got lots more deep dives into the wonders of space and time there.
So hit subscribe, stay tuned, and let's keep exploring the universe's biggest questions.